This video is of number system, unit 1 number system. So in this video we will see real number, different properties of real number. First is Euclid's division lemma. Second is fundamental theorem of arithmetic. Third, proofs of irrationality of root 2, root 3, root 5, okay, etc. And fourth is decimal representation of rational number in terms of terminating, non-terminating or recurring decimals. Okay, so here we will start with lemma. So lemma is what it is. So lemma is a statement that is proved first in order to help prove a bigger and more important result. Means lemma is, we can say in simple words, we can say lemma is it is a helpful to prove theorems. Okay, so it is a proven statement used for proving another statement. Suppose if we want to prove that addition of all the angles of a triangle is 180. Okay, means angle A plus angle B plus angle C is 180. Clear? So before that you should know that there are two parallel lines and one transversal. AB is two parallel lines, AB and CD are two parallel lines, and EF is transversal. And here 1 2 3 4 5 6 7 and 8 there are these type of angles are made, and different type of angles are co-interior angles, alternate angles, okay, like this. So this thing will helpful in proving sum of all angles of a triangle is 180. Clear? So since it is helpful, so we can say that it is just like a lemma. Clear? Now what Euclid's division lemma says, that for any two given positive integers, please remember positive integers. So positive integers are, we are saying here small a and small b, there exist unique means only one. So there exists unique whole number q and r such that a is equals to bq plus r. Again I am explaining for any two given number. So what you have to remember, positive integers as well as unique. So whenever you will write Euclid's division lemma, so just remember that you should include in your statement positive integers as well as unique whole number. Okay, in class 9th you have already seen different type of numbers. So here you have to mention unique whole number. So for any two given positive integers small a and small b, there exists unique whole number q and r such that a is equals to bq plus r, and where condition is r is greater than equals to 0 and less than b. R is greater than equal to, okay, greater than and equal to also. So greater than equal to, you can say that it is a just like inequality. Okay. So a is, small a is dividend, b is divisor, q is quotient, and r is remainder. So as you have already done in your junior classes, that how you will do division and how you will do verification of division. So in verification of division, what you did dividend is equals to divisor into quotient plus remainder. Okay, dividend is equals to divisor into quotient plus remainder. So the same thing you will do in Euclid's division lemma. Okay, so now we are taking first question, a number when divided by 73. So when divided by 73 means just pick keywords since they are saying divided by 73. Okay, so divisor is 73. Gives 34 as quotient, so they are saying, so quotient is 34 and 23 as remainder, so remainder is 23. So when you will solve your question, just first mention what your question has given. So just mention here divisor is equals to 73, quotient is 34 and remainder is 23. And now what your question demands, find the number. Okay, so first mention, don't forget to mention it, Euclid's division lemma. Okay, for this you will get number. So by Euclid's division lemma, dividend is equals to divisor into quotient plus remainder. Divisor into quotient, that will be in bracket. Okay, so according to BODMAS rule, BODMAS rule is very simple for you at this stage, but remember always, because you have to do bracket first, then whatever answer will come, that will add up with 23. So now put your given values in formula. So 73 into 34 will be within bracket plus 23. So final answer will be 2505. So what you will write? Your question demands find the number. So number is, you will write in final answer, number is, whenever you will write final answer, write number, don't write an o dot. Okay, so number is 2505 and put in block also. So your answer will be highlighted always. Okay, now we are taking second question. By what number should 1365 be divided to get 31 as quotient and 32 as remainder? So in this, what they are saying, that divided means this should be the dividend. Okay, so in solution first you will write what your question has given. So dividend is equals to 1365, quotient is 31 and remainder is 32, and do the same thing by Euclid, right here by Euclid's division lemma. Okay, by Euclid's division lemma, dividend is equals to divisor into quotient plus remainder. Put given values. Okay, and find out the final answer. So just do simple arithmetic and you will get the value of divisor and write final answer in block. So divisor is 43. Now I am explaining you fundamental theorem of arithmetic. So every composite number can be uniquely expressed as a product of prime except for the order in which these prime factors occur. So every composite number means uh, means they will come in multiples or more. Okay, so composite number can be expressed as 4, 6, 9 like this. Okay, so uniquely means ultimately, or they were means uniquely means not number other than that. Okay, so every composite number can be uniquely expressed as a product of prime. Prime means the number which are not composite, they are known as the prime, except for the order in which these prime factors occurs. So here we are taking different questions which are based on a fundamental theorem of arithmetic. So first question is, express each of the following as a product of prime factors. So 105, 462 and 651. So since they are saying prime factors, so just do prime factorization of these numbers. So while doing prime factorization, you have to do only with a smaller number. Okay, so here you are saying 3 and 5. 3 and 5, which one is smallest? So 3 is smallest, so 3 will come first. Here you are saying 2, 3, 7. So which number will come? 2. 2 will come first. You can't rearrangement of this order. If you will do rearrangement of this order, then your solution will become wrong, because you have to use smallest number or smallest digit first. So this is the prime factorization of these numbers 651. You can also do with 3 and 7. Okay. Now next question is, simplify each of the following and show that the result is as a composite number. So answer is with you. They are saying that your result in the form of composite. Okay, composite means there are two factors, means more than two factors. A number which has more than two factors, we can say that it is a composite, because prime number has always one as well as itself a given number. Okay, so here 5 into 11 into 13 plus 13. So please remember about operation also, because here it is multiplication, here it is multiplication, but here it is addition. Okay, so please cautiously do your questions which type of operation they are giving. So now we are seeing first one, 5 into 11 into 13 plus 13. So here you are seeing that 5 into 11 into 13 will become first term, and 13, another number 13 will become second term. So in both term you are seeing that 13 is common, so 13 will come out, and we will have 5 into 11 plus 1, which comes out to be 13 into 56. Okay, so 13 into 56, this given number has more than two factors. So since it has more than two factors, so it is a composite number. So what your question demands, that your final answer will come in the form of composite number. So yes, your final answer will come in the form of composite number. Now next question is 6 into 5 into 4 into 3 into 2 into 1 plus 5 plus 5. So again this will become your first term, and this will become your second term. So in both terms you will see that 5 is common. So this will come out, and remaining will inside of bracket. So just simplified, and we will get final answer. Here you are saying that this will come in the form of like this, and 145 again reduce in the form of 5 into 29. So our final answer is in the form of composite number. Okay. Next question, express 2431 as a product of prime factors. So just do with prime numbers. Here you are seeing that 2431 can be factorized by 11, 13 and 17, because we have already seen that by seeing this number we will say that it is not divided by 2, it is not divided by 5, and other numbers also. So check with 11, and after 11, 13 and 7, so it is a prime. So given number 2431 can be prime factorized by 11 into 13 into 7. Okay, now result of HCF and LCM of two numbers. What it is, that HCF into LCM can be HCF into LCM will be equal to the product of two given numbers. Or instead of product of two given numbers, we can also say that HCF into LCM is equals to first number into second number. Next is HCF divides LCM completely. So remember these things, they are very important. Now next is the HCF of two number is 116 and LCM is 1740. If one number is 580, find the other. So as we know, according to the definition of, or according to the formula of LCM and HCF, first number into second number is equals to HCF into LCM. So just put the value and let other number is x. So instead of other number we will put x, and by doing simple calculation you will get the final answer 348. So this will be the other number. Okay, your question is asking what will be the other number. So other number will be 348, and just put in block so that your answer will be highlighted. Find the largest. Next question is find the largest number which divides 245 and 1037. leaving remainder 5 in each case. So since your question is saying remainder 5 in each case, so just subtract 5 from the given number. So 245 minus 5 is 240 and 1037 minus 5 is equals to 1032. Now take HCF of 240 and 1032. So for taking HCF of 240 and 1032, first you have to do prime factorization. Okay, so by taking small numbers, you can do prime factorization of 240 and 1032. Now put here 240 is equals to 2 raised to the power 4 into 3 into 5 and 1032 is 2 raised to the power 3 into 3 into 43. So what will be the HCF? So HCF will be, we will take the common part. So 2 raised to the power 3 and 2 raised to the power 3 is in common as well as 3 is common. So 2 raised to the power 3 into 3. So 24 will be the HCF of two given numbers. Okay. Now I am explaining you different interesting facts about LCM and HCF. First is product rule. As we have seen, product rule means HCF into LCM is equals to product of two numbers. Okay. Second is if one number divides the other. As we know, HCF is the smaller number, always remember, and HCF is the bigger number. So if means if one number is a factor of the other. So this is about LCM and HCF. Okay. Third is for second we can take example also. Suppose 8 and 24. So 8 and 24 if they will give you. So you can easily judge that HCF is 8 and LCM is 24. Okay. Next is for prime factorization. If two numbers are prime and different, then HCF will 1 and LCM will be the product of numbers. For this, if we take example, suppose 7 and 13. Okay, so HCF will be 1. HCF will be 1. And if we say about LCM, so LCM will be 91. Now next is co-prime numbers. So co-prime numbers means if HCF is 1, the numbers are called co-prime numbers. So important thing about co-prime number is co-primes are not always prime. Please remember, this is again important. Okay, so for this if we take 8 and 15, so for 8 and 15 HCF will be 1. HCF will be 1, but here you are saying that 8 and 15, neither 8 nor 15 is prime. Okay. Next is LCM is always greater than the bigger number. So for this, always remember that LCM is never smaller than the largest number, either equal to it or greater than it. Okay, but never smaller than the largest number. Next is HCF is always lesser than the smaller number, means it is the same thing as fifth one, but saying in another way. Next is LCM and HCF through prime factorization. Yes, this we have already seen that through prime factorization we can easily find out. So HCF take a smallest power, whereas LCM take greatest power. And what is the shortcut trick? So if HCF is 1, if they will say that HCF is 1, so LCM will be the product of numbers. Okay, so this is all about of this video. I think this video is a little bit bigger. Hope this video will help you. Okay, thank you. Bye bye.